Hello class, Professor Anderson here. One of the coordinate systems that you need to be very familiar with is polar coordinates. So typically we're only going to worry about 2 dimensions. A lot of the motion that we deal with is just 2-dimensional. So we can have an x, y coordinate system. That is, of course, our good old Cartesian coordinate system, just collapsed into 2 dimensions. But let's say I have a point out here. And I know that it has some x, y coordinate in that Cartesian space. But now I want to define that in terms of some other variables. What could I use? Well, one possibility is how far are you from the origin? Okay? And that we typically use lowercase r. And that maybe is enough, but not quite, right? Because if I just told you r, you could be anywhere on a circle of that radius r. So we need one more variable, and the variable that we're going to use is theta. What's the orientation of that line with respect to the x-axis? And so these are called polar coordinates, r and theta. To be technically correct, the 3 coordinate systems that you need to worry about as you go further in physics are the Cartesian coordinate systems, cylindrical coordinate system, and spherical coordinate system. And this would correlate more towards the spherical coordinate system. Okay? But in 2 dimensions, we call it polar coordinates. How far are you from the origin? That's r. What's your angle relative to the x-axis? That is theta. And now you can see what happens. There is a nice little relationship between these things. So if I draw that line again, I complete the triangle, make this a right angle, and this is theta, then that xy coordinate up there corresponds to what? Corresponds to moving over in x by that amount, moving up in y by that amount. And so now we have a nice little triangle, and we know how to deal with triangles. Good old SOHCAHTOA, right? What is the cosine of theta? Somebody shout it out. Raise your hand and shout it out. What's the cosine of theta in this picture?
X over r.
Cosine theta equals x over r, right? SOHCAHTOA. Cosine is adjacent over hypotenuse. What about sine of theta? This is an easier one if we already got the first one right. Who knows what sine of theta is?
Y over r.
Y over r. Why not? Absolutely. And then finally, tangent of theta is going to be y over x. All right, so those are our nice trig relationships for this particular triangle. But we also have Pythagoras, which told us that the hypotenuse of the right triangle is the square root of the sum of the squares of the other 2 sides. Okay, so all those things describe how r and theta relate back to our Cartesian coordinates, x and y. Now there is also a very nice sign convention that we have, which is the following. Thetas that are going up are bigger than 0. Thetas that are going the other way are less than 0. Okay? Namely, if you are rotating counterclockwise, that's positive. If you're rotating clockwise, that's negative. Okay, now this is just a convention. We're not always going to use that, but that is the typical convention for these signs.